So you have a graph of f prime, and in part A, they are asking you to find all the values of x for which f has a local minimum. So when you see that word minimum, what is it that you should be thinking? You should be thinking f prime, right? So I'm going to do an f prime sign chart, and I have an f prime picture. So I should be looking for above and below. Well, if you look at your graph is always above until you get right here, which is at x equals 4. So we are above the x-axis before 4. Then we're below the x-axis next. If you look, you're below the x-axis until you get to 6. And then after that, 6. Oh my goodness. Let's try that again. Alrighty, so that's a 6. And I don't know why my pen's not working. There we go, 6. Yay! All right, and so there we go. So we are looking for a local minimum, and a minimum would be when you have a sign change from negative to positive. So then your answer will be x equals 6, and it does say you need to justify your answer. So then you could say at x equals 6 because, f prime changes from negative to positive about this point. All right, now if you look at part B, it's also talking about a minimum. However, there's 2 extra words in part B that were not in part A, and that first one is absolute, which usually means we're going to have more than one minimum, and we have to see which one is the absolute minimum. But it also says value, and remember what the word value means. Okay, so the word value means the y value. So I'm going to cheat off of part A, and also I want you to notice that they give you an interval now. So that means we need endpoints here. So we need 0, we need 8, and remember from part A we had 4 and 6, and we had positive, negative, positive, and this was the sign chart for f prime. Okay, so then from part B, we said that 6 was a minimum, which would make 4 a maximum, right? Because the signs are changing from positive to negative, which makes 0 a min and 8 a max. Okay, so then our 2 candidates for minimums would be at x equals 0 and x equals 6, right? So basically what we need to do is we need to, how about let's do this. Let's set up a chart. Okay, so we've got x values, and then we're going to figure out what f of x is, right? Oh my goodness. Okay, so we have 0, and our other option is 6. Okay, now the one thing that you do need to look back at, and I don't have it on this screen, but if you look at the original question, right above part A, it says that f of 8 equals 4. Okay, so they're giving you that. So remember, when we're determining what the y value is at 0 or at 6, we have to use that bit of information. So we're going to start with 4 plus, and then we're going to integrate. Okay, so let's think for a second. Remember, if we're using this initial condition, that 4 is this 4, and then what we do is we take the x value, and do you remember that that always becomes your bottom bound? So we're going to go from 8, and in this case we want to go to 0. Oops, sorry, I don't know why my pen's not working. And the reason why we want to go to 0 is because that's 0. So let me just stop for a second. So then if I want to figure out f of 6, I'm again going to start with that initial condition of 4 plus integral. My bottom bound, again, is always going to be 8. And this time, my top bound is going to be 6. Okay? So the value that I'm looking for, f of 0, top bound. F of 6, top bound. These bottom bounds are coming from the initial condition that they gave me. Okay? All right. So then we are going to be integrating f prime. Okay? All right. Well, you should notice that we have an issue with both of those integrals in the sense that these bounds should be flipped. Same thing here, because my lower bound here is actually bigger than my upper bound. So remember, when we flip these, we have to negate these signs. So in the next step, I'm going to write 4 minus instead, so you understand where that comes from. All right, so up here, I'm going to have 4 minus, and then essentially I'm looking for the integral from 0 to 8 of f prime. Well, this is f prime, and I want the area under the curve from 0 all the way out to 8. So I'm going to add 2 and 6. Then I'm going to subtract 3 because that's negative. It's underneath the x-axis. And then add 7. Okay? All right, so let me show you. So again, I'm going to add 2 plus 6 minus 3 plus 7. And I'll work that out. I'm going to put that answer down here. And I'm going to do the same thing for this one. So it's going to be 4 minus, and then this time I'm just going from 6 to 8. So that would be this space right here, right, which would be 7. But remember, that's a minus sign, so 4 minus 7. So this one we know is negative 3. So there's f of 6. That's negative 3. And then my f of 0, when I work that out, is going to be negative 8. Okay, so reread the question. It says determine the absolute minimum value. So which one of these is more min? And that would be negative 8. So the absolute minimum value would be negative 8. All right, so part C is asking on what open interval or intervals between 0 and 8, but not including the endpoints, is the graph concave down and increasing. Okay, so increasing would be the derivative. So I just redrew the sign chart from part A and from part B. So hopefully you can see then that we're increasing from 0 to 4 and also from 6 to 8. Okay, now concave down means second derivative, right? So we need to do a second derivative sign chart. What do we look for? Because I have a first derivative picture. We look for increasing and decreasing, correct? So I've got decreasing till I get to 1. Then I'm increasing till I get to 3. Then I am decreasing until I get to 5. And then I am increasing after that. Okay, so we're looking for concave down. So concave down means that f double prime is going to be negative. Increasing means that f prime is going to be positive. Okay, so if you look, you should see 0 to 1 will be the first place that will happen. So let's look. 0 to 1 here is negative. Second derivative is negative. And 0 to 1 here, the first derivative is positive. First derivative is positive. Okay. All right. Let's look and see if we can find some other places. Can you find the other place where this will be the case? Okay. Pause me and see if you can figure it out. All right. So that would be from 3 to 4. So again, from 3 to 4, the derivative is positive. and it is the second derivative is negative. So 3 to 4. Okay, so these would be your two values right there. All right, last part. So they want you to find the slope of the line tangent to the graph of G. Slope, G, I would think derivative, right? So I'm going to take the derivative of the G equation that they gave you, which is going to be 3 times f of x, that quantity squared, times f prime of x. Okay, so there's the general derivative. Now what we have to do is we have to plug in 3, right? So g prime of 3 equals 3 times f of 3, that quantity squared, times f prime of 3. All right, so let's see what we can find out. So we know that this is 3. Okay, so what we need to do is we need to find f of 3. All right. Well, if you read the question, it says right here that f of 3 is negative 5 halves. So that's going to be negative 5 halves, and then that quantity squared. Okay, now f prime of 3, well, this is the graph of f prime. 1, 2, 3, follow it up, and that's 4. So then we know that that's 4. Okay, why don't you take a minute, pause me, and see what you get. All right, that's what I have, 75.